So within 30 minutes, I'll try to complete this aromaticity concept. Then we'll move on to the reactive intermediates. Hope my screen is also visible to you. So the aromaticity, what we have discussed in the previous sessions, aromaticity, okay, it should be cyclic, planar. Every atom should have a p orbital, so that the delocalization or complete conjugation should be favorable. Then it should obey 4n plus 2 pi electron. Okay, so n value should be whole number. 4 criteria obey பண்ணுச்சு அப்படின்னா அந்த காம்பவுண்ட் அரோமேட்டிக்னு சொல்லுவோம். ஆன்டி அரோமேட்டிக் அப்படின்னா ஃபர்ஸ்ட் 3 criteria are same. It should be cyclic, planar, conjugation should be there. Instead of 4n plus 2 pi electron, it should obey 4n pi electron. அது இருந்தது அப்படின்னா ஆன்டி அரோமேட்டிக் அப்படின்னு கிளாஸிஃபை பண்ணோம். நான் அரோமேட்டிக், லேக் ஆஃப் ஏதாவது 3 criteria ஏதாவது ஒன்று இல்லைன்னா கூட you can consider those compounds as non aromatic. தென் ஃபுல் வால்யூம் டைப்ஸ் காம்பவுண்ட்ஸ்லாம் பார்த்தோம் நம்ம. ஸோ அதனுடைய கான்சிக்வன்சஸ் எப்படி இருக்கும், என்னென்ன ப்ராப்பர்ட்டிஸ் அஃபெக்ட் பண்ணும், எதெல்லாம் நீங்கள் ப்ரெடிக்ட் பண்ண முடியும். ஓகே, பேஸ்ட் ஆன் தி aromaticity கான்செப்ட். ஸோ யூ கேன் ப்ரெடிக்ட் த ஸ்டெபிலிட்டி ஆஃப் தி அயான்ஸ், அண்ட் ஆல்சோ யூ கேன் ப்ரெடிக்ட் தி அசிடிட்டி ஆஃப் அ காம்பவுண்ட், தென் ரேட் ஆஃப் தி solvolysis reactions and dipole moment and cis trans isomerization. So the stability of ions, suppose so they have given these two compounds. So among these two, which is more stable, first one or second one?
First, sir.
Why?
Sir, it is aromatic.
Yes. So the cyclopentadienyl anion, 6 pi electrons are there. 4n plus 2 is equal to 6. 4n equal to 6 minus 2, 4. N value will be 1. This compound is aromatic. This is a cyclopropenyl anion. 4 pi electrons. This compound is anti-aromatic. So நம்ம stability பார்த்தோம். So aromatic compounds are more stable. Anti-aromatic compounds are least stable. Am I right? In the stability order. Hence, aromatic compound is more stable. This ion, cyclopentadienyl anion, is more stable. Okay. Then acidity. So among these two, which is more acidic? So acidic compound means which gives H plus ion. Okay. Cyclopentadiene, first one.
First one.
How?
When H plus goes,
Because if it donates a proton, it will become aromatic.
Yeah. If it donates a proton, here there are two protons are there. Okay. If it donates a proton, it becomes cyclopentadienyl anion, which is aromatic. And this is cyclopropene. After losing its proton, it becomes cyclopropenyl anion, which is anti-aromatic. Okay. Look at this. So acidity means it should donate a proton, H plus. It goes like this, and this electron goes to this carbon. Okay, it becomes carbanion, cyclopentadienyl anion. This compound is aromatic. Cyclopropene, after losing its proton, it becomes cyclopropenyl anion. Okay, this compound is anti-aromatic. Hence, this compound readily gives its proton because it attains aromaticity. Okay. This compound is, what is the nature of the cyclopentadiene? This one?
non-aromatic.
Yeah, very good. This is non-aromatic because it is sp3 hybridized carbon. Non-aromatic becomes aromatic. Hence, stability. Okay, it gains the stability after losing a proton. That's why it readily loses a proton. This compound is more acidic. Okay, like this you can predict the acidity of an organic compound. Okay. So phenylene is acidic in nature. Look at this. So this is the structure of phenylene. Why this is acidic? Highly acidic. Because look at this. After losing a proton, it becomes carbanion. Then it obeys 4n plus 2. How many pi electrons are there in this?
14.
Yeah, 1, 2, 3, 4, 5, 6, 7. Yeah, 14 pi electrons. 4n plus 2 is equal to 14. 4n equal to 14 minus 2, 12. Okay, you'll get 3. N value 3. Cyclic இருக்கும், planarity இருக்கும். Okay, complete conjugation is also possible. And this compound is non-aromatic. Here it is sp3 hybridized carbon. That's why phenylene is more acidic. Look at this. Which of the following compound is more acidic? I have given 3 compounds. A question from Naveen Raja. Sir, aromatic compounds have greater acidity always. Yes, if there is a tendency. Okay. H plus lose பண்ணதுக்கு அப்புறம் if it attains aromaticity, then that compound will be more acidic. It's a relativity. Okay. I'm going to compare the relativity. Naveen Raja, A, B, C மூணுமே acidic compound இருக்கும். But the tendency in the compound readily it donates H plus. Yeah, it is more acidic. What happens after losing a proton in a compound? I mean, carbanion will be formed like this. In B, in C. Look at this. எல்லாமே aromatic part. Am I right? So the circled part is aromatic. Compare the aromaticity of these three.
Sir, C is more aromatic.
Okay. How? Can you explain?
So there is 3 aromatic structures there, so it is more aromatic.
Okay, what happens? What happens? So these 2 rings are aromatic. Okay. Then the delocalization takes place in, I can say this is ring A, ring B. So whether the aromaticity is decreased in the circled cycles? Okay, I'll explain. So this is more stable and this is less stable. Hence, this compound is more acidic. So this is known as annulation effect. Look at this. So this is the acidic strength. Look at the pKa value. So pKa value of this compound is 16. This is 20. This is 23. Any compound which is having lesser pKa will be more acidic. Okay. So an acid compound of Ka value should be high. pKa value should be low. Okay. And this is more acidic. So this is annulation effect. I'll explain. Look at this. If the aromatic ring is directly attached to another ring, then the aromaticity is transferred from one ring to another ring. Look at this. So this is ring B, this is ring A. So this is the aromatic part. The aromaticity is attached with another aromatic ring. Then the aromaticity of this ring A is transferred to the nearby ring, that is B. Hence, this the ring A aromaticity is decreased. Similarly, here adjacent nearby there are 2 rings, ring B and I can say ring C. Hence, the aromaticity of ring A is further decreased. Are you able to follow? The aromaticity of ring A is decreased because adjacent there is 2 aromatic rings. So the calculation of electrons. This ring A, the aromaticity is drastically decreased and it is transferred to the nearby ring, that is B and that is to C. So this is annulation effect. Then rate of the solvolysis reaction. So which of the following halide will undergo solvolysis at a faster rate?
Sir, but the
They
resonance
have
structure
given,
C க்கு தானே சார் நிறைய வரையலாம்.
yeah, resonance structure is more, but which ring is going to donate a proton? Not B, not C. Only ring A is going to donate a proton because it is having a saturated carbon. Okay, so the tendency of losing a proton is based on the stability of ring A. Okay, that is why the aromaticity is decreased. The acidity will also be decreased.
Okay, sir.
I'm going to compare only the stability of this part. Maybe the resonance structure is more, but the tendency of losing proton, after losing a proton, what happens to this ring A? Okay, that is the concept.
Okay, sir.
Yeah. Then solvolysis reaction. So among these two, which will undergo at a faster rate?
Sir, second.
First one.
Second. Okay. What do you mean by solvolysis? So in the presence of solvent, okay, it loses SN2 type. Okay. Nucleophilic, bimolecular nucleophilic substitution reaction where solvent acts as a nucleophile. What happens? It goes as a Br minus, then there's a formation of cation. The first step, there is a formation of cation, this cyclopropenyl cation. Into, after losing, yeah, it goes as a bromide ion, then cyclopentadienyl cation. Among these two, which is more stable?
First one.
First one, because it obeys 4n plus 2 pi electron, cyclic planar conjugation is there. What about this second one?
It is anti-aromatic.
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 4 pi electrons, it is anti-aromatic. Okay, hence this will undergo solvolysis at a faster rate. Solvolysis ஆனதுக்கு அப்புறம் it attains aromaticity. Okay, so this is a non-aromatic compound gains aromaticity after solvolysis. Then, so this halide will undergo solvolysis reaction at a faster rate. Look at this. Which will undergo solvolysis at a faster rate? 1 or 2? The same concept. SN2, first step, there is a formation of
Second one.
cation. Second one,
One, sir. One.
yeah,
Non-aromatic இருக்கும், so stable.
yes. So when compound 1 is treated with silver perchlorate, so this will undergo rapid hydrolysis, solvolysis reaction. Look at this. So this is a simple carbocation. The same condition, compound 2 does not undergo solvolysis because it attains anti-aromatic character. This is a simple carbocation. Okay, so this is more stable than the anti-aromatic compound. You have to compare the stability of the formed ions. Anti-aromatic is least stable, as we know. So this is a simple carbocation. It is this is secondary carbocation. Okay, this is stabilized by hyperconjugation or plus I effect. This is more stable. Here there is no stability. Okay, friends, this will undergo solvolysis at a faster rate. This halides. Then dipole moment. How do you predict the dipole moment of any compound using aromaticity concept? So dipole moment, which is nothing but as a result of unequal sharing of electrons. Look at this. Among these two, which is having a higher dipole moment?
Sir, second structure.
Second structure. Okay. Look at this first one. So the electron displacement we have discussed in the fulvalene type compounds. Okay, electron displacement can take place like this, and this part is anti-aromatic, this part is aromatic. The overall compound is
Non-aromatic.
Yeah. So this is aromatic part. This is anti-aromatic part. Look at this. This part is aromatic, and this part is also aromatic. Hence, the displacement of electrons favors in 2. Hence, this compound is having more higher dipole moment. Is it clear? It attains stability. Then this compound will undergo isomerization. I'll explain the next terms. Dipole moment. Look at this. So which is having a greater dipole moment, 1 or 2? Yeah. Because this oxygen is more electronegative. Okay. The displacement of electrons. Then this part gains aromaticity. Cyclopropenyl cation. And in compound 2, what happens? Look at this. So this is not aromatic. Okay. Hence, compound 1 is having greater dipole moment. Then cis trans isomerization. Look at this. Among these two, which will undergo isomerization? There is a cis trans isomerization. Cis trans isomerization நடக்கணும்னா displacement of electrons. Okay. Which one?
Sir, second structure.
Second structure. In structure 1, so this is the displacement of electrons. In structure 2, and this is. Then predict the stability of these two, which gains stability after displacement of electrons.
Second structure.
Sir.
This part is also aromatic, and this part is also aromatic. Not structure 1, because this is anti-aromatic. Cyclopropenyl anion. Even though this part is aromatic, okay, this part is anti-aromatic. The overall compound is it's non-aromatic, right? So aromatic, this is aromatic. Hence, this is the lowest energy barrier. Okay, because displacement of electrons favors the aromaticity. I think this is the problem I have given in the last class. So I will show the answer at the end. Okay, you can check. Then we'll discuss some problems from the previous year question papers. So you can refer Claydon, Carey and Sunberg, Jerry March for So is there any doubts from the concept of aromaticity?
சார்
Any
ஒரே ஒரு டவுட்
clarification?
சார்.
Yes.
சார் அரோமேட்டிக்கும் நான் அரோமேட்டிக் ஆன்டி அரோமேட்டிக் சேர்ந்தா நான் அரோமேட்டிக் காம்பவுண்ட் ப்ரொடியூஸ் ஆகும் சார். எல்லா கேஸ்லயுமே அப்ளை ஆகுமா இல்ல?
எந்த கொஸ்டின் கேக்குறீங்க?
இல்ல சார், இதுக்கு நம்ம டிஸ்கஸ் பண்ணோம்ல சார் இப்போ
எஸ்.
ப்ரீவியஸ் ஸ்லைட்ல. அரோமேட்டிக் அண்ட் ஆன்டி அரோமேட்டிக் சேர்ந்தா வந்து நான் அரோமேட்டிக் ஃபுல் வால்யூம்.
எஸ் எஸ். ஆமா, அது ஆன்டி அரோமேட்டிக்கே இருக்காது. எல்லாத்துக்கும் எப்படி? அது ஃபுல் வால்யூம் டைப் காம்பவுண்ட்ஸ் மட்டும். ஃபுல் வால்யூம் டிஸ்கஸ் பண்ணீங்களா?
ஆமா சார்.
That is applicable to that full volume type compounds also. ஏன்னா அங்க மட்டும் தான் ரெண்டு ஸ்ட்ரக்சர் இருக்கும் உங்களுக்கு. இது எல்லாமே
ஓகே சார்.
மோனோசைக்ளிக்கா இருக்கும். இந்த எக்ஸோசைக்ளிக் டபுள் பாண்ட் இருக்கிற இடத்துல மட்டும் அப்ளிகபிள் ஆகும்.
ஓகே சார். ஓகே சார்.
We'll discuss quickly these previous year question papers. So among the carbocations given below, which is the correct one? So this is a question asked in CSIR June 2011. கொஞ்சம் ஃபாஸ்டா டிஸ்கஸ் பண்ணோம் அப்படின்னா நம்ம
Option A,
Sir,
sir.
A, sir. A,
Option
A answer.
ஒரே ஒரு ஆப்ஷன் தான் கரெக்டா இருக்கும். ஏ அண்ட் சி கிடையாது.
ஏ சார்.
Multiple choice question.
Option A, sir. A, sir. Option.
You can predict the stability from known to unknown. Okay. So far we have discussed cyclopropynyl cation is aromatic. Am I right? இது நமக்கு தெரியும் எனக்கு. ஏன்னா இது கூட A, B கூட if you don't know. So we have discussed so many problems based on cyclopropynyl cation. This is aromatic. Among the given option A is only applicable. Okay, C is homoaromatic கொடுத்திருக்காங்க. We can eliminate B, C and D. Okay, look at this. A is homoaromatic. Homoaromatic means this C gas, this sp3 hybridized carbon is forced to above the ring. So conjugation பார்த்தோம் அப்படின்னா இந்த கார்பனுக்குள்ள தான் இருக்கும். Okay, hence this is a homoaromatic compound. Look at this. 4 pi electrons. It obeys 4 and pi electron. This compound is anti-aromatic. Okay, hence option A is the correct one. Second question. The correct order of acidity of the following compound. Acidity. After losing a proton, which anion will be more stable?
A greater than B greater than C, sir.
So option D.
Option D, sir.
Answers from other students also. You can post your answers in the chat box. You can check. So acidity means in the compound readily donates a proton. H plus கொடுத்ததுக்கு அப்புறம் இந்த கார்பன் gains a negative charge. You know that? Okay. இப்போ கம்பேர் பண்ணுங்க stability of these three anions. B என்ன ஆகும்?
Anti-aromatic.
Anti-aromatic.
C?
A greater than C greater than B.
Yeah. Look at this. After losing proton, yeah. Among these three, this compound is aromatic. Okay. In the presence of electron withdrawing group, increases the aromaticity. Okay. Anti-aromatic, and this is also aromatic. Compare A and C. C is more aromatic. Electron withdrawing group or minus I effect favors the delocalization. For this, more aromatic due to negative inductive effect of a fluorine atom, minus I effect, and this is less aromatic due to plus I effect, an electron donating nature. So the correct answer is option C. Okay. So நிறைய பேர் ஆன்சர் கரெக்டா கொடுத்திருக்கீங்க. Yeah. Good. Next question. Among A, B and C, which is aromatic?
Option
B and C only, sir. C.
B and C.
B
This
and
is
C
aromatic,
only,
we know. Yeah, naphthalene. And look at this. What is the structure of compound B?
Bridged annulene.
Very good. So bridged head. The oxygen எப்படி இருக்கும்? Above the plane இருக்கும். Okay. Which will not disturb the delocalization of these electrons. Okay. And this is இங்க ரெண்டு ஹைட்ரஜன் இருக்கும். Non-planar structure இருக்கும் A. But this. So this is a non-planar, hence non-aromatic. B is aromatic. C is also aromatic. So the correct answer is option C. Look at this. The correct order of acidity of the compound.
C sir, squaric acid more acidic.
Yeah, squaric acid we have discussed. Highly acidic. Then
A sir, and then B.
chat boxல ஆன்சர் யாருமே கொடுக்கலையே. Post your answer in the chat box. You can see. Okay. As we know, the acidity is directly proportional to electron withdrawing ability. சரிங்களா? After losing a proton, it will form like this. B forms, and this is squaric acid. So the acidity you can compare with the sulfuric acid. So அந்த அளவுக்கு strong acidic இருக்கும். It is also aromatic. Very good. Option C is the correct one. Why B is less aromatic சொல்றோம்?
Relation effect, sir.
Yes. So the aromatic character of this compound is decreased. Look at this. Consider the following statement for 18 annulene. The correct statements. So we have discussed 18 annulene. அதனுடைய proton என்ன மாதிரி discuss பண்ணோம். Whether 18 annulene is aromatic?
Yes, sir.
Yes,
Sir, aromatic.
Option mean the statement correct. Okay. Then inner proton and outer protons. அதனுடைய delta value, chemical shift value. Option D சொல்றீங்க கரெக்டா? A and C only.
Sir, option A sir, A, B, C both are.
Option A சொல்றீங்களா? A, B, C மூணுமே கரெக்டா? Inner protons, 6 inner protons are there. Shielded zone இருக்கும். Shielded zone இருந்தது அப்படின்னா delta value எப்படி இருக்கும்? முன்னாடி சொன்ன D, D.
கம்மியா இருக்கும்.
Negative, sir. Negative.
Yes, negative. Very good. So D shielded zone அப்படின்னா downfield. Okay, I'll show the component. Yeah, look at this. These 6 protons எந்த zoneல இருக்கும்?
Shielded zone.
Shielded zone. இங்க இருக்கிற outer protons
D shielded.
Deshielded.
D shielded proton. Look at this. Shielded proton. So அதனுடைய delta value chemical shift value நெகட்டிவ்ல இருக்கும் -3 ppm. outer protons இருக்கு பாத்தீங்களா? D shielded proton. D shielded அப்படின்னா downfield. So downfield அப்படின்னா delta value அதிகம். Look at this 9.3 ppm. Hence the statement A and C are correct. இதுல கன்ஃபியூஸ் ஆகக்கூடாது. ஓகே, shielded proton அப்படின்னா upfield. சரிங்களா? என்னமா ஸ்பெக்ட்ரம் படிச்சதா தெரிஞ்சிருக்கும். இங்க 0 இருக்கும் TMS. So this is a downfield. delta value அதிகமா போயிட்டே இருக்கும். இந்த சைடு போனா upfield. Okay, negative delta value. D shielded proton. D shielded வரும் downfield வரும். downfield அப்படின்னா delta value அதிகம். Like this 1 2 3 அதான் 9.3 ல வரும். So these 6 inner proton shielded zone, highly shielded. Then upfield, so negative value. So option D is correct. A and C. Among the following, the compound which has the lowest energy barrier. CSIR December 2013.
Option C,
Sir,
sir.
C.
C. Because it attains aromaticity, right? This part is cycloheptatrienyl cation. This is cyclopentadienyl anion. Look at this. So ரெண்டு பார்ட்டையும் கம்பேர் பண்ணணும். ரெண்டுமே aromatic வந்தா தான் the whole structure is aromatic. ஏதாவது ஒன்று ஆன்டி அரோமேட்டிக் வந்தா the compound becomes non aromatic. சரிங்களா? இந்த மாதிரி டைப் காம்பவுண்ட்ஸ்ல ஆன்டி அரோமேட்டிக்கே கிடையாது அப்படின்னு சொன்னோம். So this is non aromatic. This is also non aromatic. So C is the correct one. Lowest energy barrier, so that it attains aromaticity. The compound that is anti-aromatic. CSIR December 2014 question is In the compound anti-aromatic.
4, sir.
A.
4 நல்லா பாருங்க.
First one.
In 4 ல என்ன ஆகுங்க? Oxygen is more electronegative. Displacement of electrons goes like this. This becomes
Yeah, sir.
negative. This becomes positive. Cyclopropenyl cation is aromatic.
Yes, sir. Yes, sir. A.
Yes, A is the correct one. இங்க பாருங்க sp3 இருக்கு. It becomes non-aromatic. Okay. This is the explanation. So answer A is the correct one. The compound that gives precipitate on warming with aqueous silver nitrate. Yes. CSIR June 2015. In the compound, readily it gives precipitate. Silver nitrate को treat பண்ணும்போது என்ன நடக்கும்?
Br minus போயிடும்.
Yes.
C, sir.
SN2 type solvolysis reaction மாதிரி. Option C. Why?
Sir, the quasi-aromatic வச்சு
After
பார்க்கணுமா, sir?
the removal of Br, it becomes aromatic, sir.
Yes. என்ன ஆகும்? Br minus போயிடுச்சு அப்படின்னா carbocation form ஆயிடும். This part
Stable carbocation.
aromatic. I can say aromatic. சரி carbocation எங்க சொல்லுவோம் அப்படின்னா aromaticity இல்லைன்னா you can simply say carbocation. ஓகேங்களா, இதுவும் carbocation தான், but it attains stability. எஸ்பெஷலி சொல்ல போனோம் அப்படின்னா குவாசி அரோமேட்டிக் சொல்லலாம். ஸோ குவாசி அரோமேட்டிக் மீன்ஸ் அயானிக் காம்பவுண்ட்ஸ். எங்கெல்லாம் சார்ஜ் வந்து இன்வால்வ் ஆகுதோ அரோமேட்டிசிட்டியில் அதெல்லாமே குவாசி அரோமேட்டிக் சொல்லுவோம். ஸோ காம்பவுண்ட் சி இஸ் தி ரைட் ஒன். லுக் அட் திஸ். ஸோ திஸ் காம்பவுண்ட் இஸ் ஆல்ரெடி அரோமேட்டிக். bromobenzene is aromatic. Here the aromatic is disturbed after reacting with silver nitrate. And option B, there is a formation of anti-aromatic. This is also so here also aromatic is disturbed. So C is the correct one. Next question. So correct match of the product of the reaction column A with the properties of column B. What will be the correct option? We have discussed this and these three we have discussed in our session. Option A. Okay, look at this. It forms a corresponding dianions. This is aromatic. Look at this. After reacting with sulfuric acid, this attains homoaromaticity. Option C. It forms this compound. This structure, it forms 16 pi electrons. Hence, it is anti-aromatic. Yes. Option A is the correct one. So this is option A structure. This is aromatic. This is homoaromatic. Because it is sp3 forced to above the plane, and this is non-aromatic, non-planar. We have discussed. This is 16 pi electrons. It obeys a 4n pi electron rule. This ion is anti-aromatic. So A is the correct one. Look at this. Which is the correct statement about A and B?
B, sir.
Option B.
Option B, sir.
Bharat. Option B. Let me check. Look at this. cyclooctadiene in a dication of cyclooctatetraene. We have discussed. So this is aromatic, and look at this cyclic planar conjugation. Number of pi electrons involved here, it is 8. It obeys 4 and pi electron. This is anti-aromatic. Okay. So B is the correct one. Good. Look at this. So this is a recent question asked in CSIR examination the last month. Which of the following species is aromatic? Option D, only A and B. Yeah. Dana Lakshmi, you have said the C. Only B and C. So identify the number of pi electrons in C. How many pi electrons involved in delocalization? 3, 4, 5, 6. 12 pi electrons. 12 pi electrons to obeys 4 and pi electron rule. Okay. Look at this. Cyclic planar conjugation is there. Number of pi electrons, 6 pi electrons involved. Obeys 4 and plus 2. Aromatic. Where it is cyclic planar conjugation. How many pi electrons are involved in delocalization in structure B?
10, sir.
Yes. So lone pair on sulfur atom. It 10 pi electrons. 2, 4, 6, 8. These two. These two electrons. One lone pair. So number of pi electrons involved in delocalization is 10. It obeys 4 and plus 2. Look at this structure C. Cyclic planar conjugation is there. It obeys 4 and pi electron because the number of pi electrons involved in delocalizations are 12. So it obeys 4 and pi electron. N value is 3. 4 and plus 2 போட்டிங்கன்னா வராது fractional வரும். Hence A and B is only aromatic. Yes. So this is a gate question. The compound that is not aromatic.
Option D, sir.
Option in the chat box.
Sir, B. B, sir, B.
Option D, sir.
So this A is aromatic, B is anti-aromatic, C is aromatic, cyclopentadienyl anion, and this is also aromatic. Okay. Cyclooctatetraene உடைய corresponding dication, dianion, ரெண்டுமே aromatic. So option B is the correct one. Look at this. The compound is which option is correct with respect to this compound? So this is the gate question.
Option A, sir.
Option A. So this is azulene, right? Azulene is aromatic, which is having appreciable dipole moment. கண்டிப்பா இருக்கும்னு பார்த்தோம் நம்ம. Okay. So A is the correct one. So this is the resonating structures of azulene. So the dipole moment is 0.8 dB. So A is the correct one. Good. Next question. Among the following compounds, the one that is non-aromatic. Gate 2015 question. Is it non-aromatic?
Option A, sir.
A.
Option
A.
cyclooctatetraene. This is benzene, aromatic. Option C, anti-aromatic. Option D is also
Aromatic.
aromatic. Okay, aromatic. Look at this. Non-aromatic. Benzene is aromatic. Cyclobutadiene, anti-aromatic. This compound is aromatic. Okay. So the gate 2020 question. Among the following, the total number of aromatic species. இது எல்லாமே நம்ம கிளாஸ்ல டிஸ்கஸ் பண்ண எக்ஸாம்பிள்ஸா தான் இருக்கு. The number of aromatic species, 4. Aruna Rajagopal, you are told 3. So I am expecting more responses in the chat box. Naveen Raja 3, Satish 4, Ritika 4, Riyaz 3. Okay, I'll show the answer. Look at this. So this compound is non-aromatic because it is sp3. Still I'm getting answers. Subasti 3, 4. So answer will be 3 or 4. Okay, let me explain. So the first is non-aromatic. sp3 hybridized carbon இருக்கு. Second option பாருங்க aromatic. Third is cyclopentadienyl cation, anti-aromatic. Cyclobutadiene is also anti-aromatic. Cyclopropenyl cation is aromatic. So this is phenylene anion is aromatic. So this is pyrrole aromatic. Cycloheptatrienyl anion. Cycloheptatrienyl anion anti-aromatic. So 4 is the correct one. 3 ன்னு சொல்லுவாங்க, எங்க மிஸ் பண்ணீங்கன்னு தெரியல. ஹரிணி எந்த இடத்துல ஏதோ அரோமேட்டிக் காம்பவுண்ட் மிஸ் பண்ணீங்க? Pyrrole, one lone pair. Second one, yeah. Only 6 pi electrons are involved in delocalization because there is a positive charge on oxygen. Okay, அப்ப 8 ன்னு கவுண்ட் பண்ணிருப்பீங்க. So answer is 4. So this is JAM 2021 question. Among the following, the anti-aromatic compounds. So this is multiple select question. More than one options will be there. This is anti-aromatic.
B and D, sir.
Yeah, B and D. A is non-aromatic, right? This is what about C?
Aromatics.
Yes, aromatic. அப்ப ஏன் B, D போனீங்க? Anti-aromatic. Okay. 1, 2, 3, 4. 8 pi electrons are involved in this structure. So B, C and D is the correct one. The rate of solvolysis. So JAM இந்த மாதிரி related questions கேக்குறாங்க 2020. The rate of solvolysis. Solvolysis. First step, there is a formation of carbocation. இந்த எல்லாத்தையும் carbocation. Plus charge போட்டுக்கோங்க.
Option C, sir.
Option C, yeah.
C.
Okay. Answers from other students. Naveen Raja C, Sahib B. கொஞ்சம் திங்க் பண்ணீங்க கரெக்டாக சொல்லிடலாம். ஹரிணி சி, ரியாஸ் சி. Yes. So this is cyclopropenyl cation, aromatic, right? So given options la paakren 3 is aromatic, so that I can neglect or I can remove option A and B. சரிங்களா, வராதுன்னு I can neglect. Compare B and C. Look at this 4. 4 is anti-aromatic. அப்போ அதான் லீஸ்டாக இருக்கும். ஸோ B and C லையுமே you cannot eliminate 4. So you have to compare 2 and 1. 2, 1, 1. ரெண்டுல எது மோர் ஸ்டேபிள்னு பார்க்கணும். ஸோ இங்கே பார்த்தீங்கன்னா பிரிட்ஜ் ஹெட் கார்பனில் there is a positive charge. ஓகே, அக்கார்டிங் டு பிரெட்ஸ் ரூல் இது கண்டிப்பாக லீஸ்ட் ஸ்டேபிளாக இருக்கும். லுக் அட் திஸ். ஸோ திஸ் கேன் பி ஸ்டெபிளைஸ்டு பை this by electron. Okay, 2 is more stable. So hence C is the correct one. I can give the explanation. Look at this. This is aromatic. This is anti-aromatic. So this is allyl carbocation. This can be stabilized by this. So this is bridgehead carbocation, least stable. So C is the correct one.
சார் ப்ரீவியஸ் ஸ்லைடு மட்டும் காமிங்க சார் கொஸ்டின் மட்டும்.
Question. Yes.
தேங்க்யூ சார்.
Okay. Then the reaction that results in the formation of aromatic species. JAM 2019 question. எந்தெந்த ரியாக்ஷன்லாம் அரோமேட்டிக் ஸ்பீசிஸ் ஃபார்ம் ஆகும்? Multiple select question is it? So more than one option will be the correct. எந்தெந்த ரியாக்ஷன்லாம் அரோமேட்டிக் ஸ்பீசிஸ் ஃபார்ம் ஆகும்?
C and D, sir.
C and yeah, I'll explain. Look at this first reaction. ஏன் ஆப்ஷன் ஏ விட்டீங்க? Cyclopropynyl cation will be formed. Option B anti-aromatic வரும். Option C cyclopropynyl anion form ஆகும். Option D cyclopentadienyl anion. A and D ரெண்டு ஸ்பீசிஸ்ல மட்டும்தான் there is a formation of aromatic ions in the reaction A and D. Okay. The correct order is rate of solvolysis. JAM 2017. Rate of solvolysis. A and C. Previous question. Okay. Answer for this question. Option D.
D, sir.
Naveen Raja D. Because there is a formation of tropylium ion. Okay. Look at this. This is anti-aromatic. This is aromatic. This is benzyl carbocation. So D is the correct one. Yes. Among the following, the number of molecules that are aromatic. JAM 2016. So numerical answer type. So கொடுத்திருக்க molecules எல்லாம் ஆல்ரெடி நம்ம செக்ஷன்ல டிஸ்கஸ் பண்ணதா.
3 sir.
Only 3. 4 3 ரெண்டு ஆப்ஷன்ஸ் வருது. ஓகே. 4 3 or 4. Okay, I'll explain. Look at this. First one is anti-aromatic because 8 pi electrons are involved. Second one is tub shape cyclooctatetraene, non-aromatic. Third one is azulene, aromatic. This is heptylene, anti-aromatic because 12 pi electrons are involved. Third one is aromatic. Exocyclic double bond, delocalization putting it attains aromaticity. Then this compound is aromatic. Nitrogen lone pair இருக்கும். This is non-aromatic. Rendu hydrogen. It's a non-planar structure. Last one is a pyrene type compound. Okay. So delocalization. Peripheral carbon atoms மட்டும் தான் delocalization involve ஆகும். You don't worry about these two carbons. Hence this is aromatic. யாரெல்லாம் 3 ன்னு சொன்னீங்களோ you can check. Okay. So 4 is the correct one. Which of the following species are aromatic in nature? Jam 2015 question இது. Multiple select question.
Option A, sir.
Option A.
A and C, sir.
Others? Option A and C.
A, B, C.
A and B. I'm getting different answers. A, B, C. Look at this. This is aromatic. How many pi electrons are involved in option A?
Anything involved.
Only 6 pi electrons. Nitrogen lone pair does not involve in the delocalization. Okay. Option B is also aromatic. Here also 6 pi electrons are involved. It's also aromatic. Because 14 pi electrons involved, it obeys 4n plus 2. Option D, 8 pi electrons are involved. So A, B, C. Okay, almost the correct answer. So A, B, C compounds are aromatic. Okay. So oxygen ரெண்டு லோன் பேர் இருக்கும், ஒரு லோன் பேர் மட்டும் delocalization involve ஆகும் இங்க. So 8 pi electrons are involved, it obeys 4n pi electron rule. So correct answer is option A, B and C. So Calicene is polar hydrocarbon with a high dipole moment, the most stable dipolar resonance structure. Jam 2013 கேட்ட கொஸ்டின் இது. இதனுடைய resonance structure கேக்குறாங்க. Most stable resonance structure. So this is the structure of Calicene. Displacement of electrons towards எங்க வரும்?
5 member
Sir,
in
Towards five
cyclopentadiene
member.
anion, sir. Yeah.
Or like this. எது வரும்? இது pathway A. You can
Sir,
say
first
this.
put arrow, sir.
sir. Yes,
Yeah.
sir. Yes.
A, sir. A.
Plus இங்க வந்துரும் நெகட்டிவ் சார்ஜ், இங்க வந்துரும் இங்க பாசிட்டிவ் சார்ஜ். Okay, so this part is also aromatic and this cyclopentadienyl anion is also aromatic. So this is the correct more stable resonance structure. இந்த மாதிரி இருந்தப்போ அந்த காம்பவுண்டுக்கு polarity இருக்கும், dipole moment இருக்கும். Okay, so thank you. இது வரைக்கும் aromaticity almost I have discussed all the important topics. Craig's rule லாஸ்ட் கிளாஸ்ல கேட்டீங்க, பட் Craig's rule வந்து சில காம்பவுண்ட்ஸ் மட்டும் அப்ளிகபிள். ஓகே, அதே மாதிரி ஃப்ரோஸ்ட் டயக்ராம் அதெல்லாம் இல்லாமலே யூ கேன் ப்ரெடிக்ட் தி கரெக்ட் ஆன்சர்ஸ் பேஸ்ட் ஆன் தி aromaticity concept. Then we'll move on to the next topic, reactive intermediates. So these are all some reference books I have referred to prepare the slides. So I have referred some journals also.